Well, welcome back, and this is the second part of Lecture 5 on interacting classes. This is Chapter 3 of the textbook Nino. Make sure you take a look at that as soon as you can. So from now, for this chapter, what we're going to look at is how classes interact. And we had this example of a player object. So remember the rounded corners of a square, that means that you have an object, these are data members, and these are values of these data members. So this is our chess game example where we have a player calls the current square method of the piece object. So this piece in this case is a queen, a white queen. That's assuming that the player is one of the is the white player as opposed to the black player. And then the piece has also color, rank, and position or square. So let's say you have a current square method. It returns the value that's stored in the square data member, which is just D1. So here's the query, current square. It returns the value D1, and the player does whatever it needs to do with that information. So this is the same example basically as from the last chapter, or actually from the last set of lecture notes, which was on inheritance, polymorphism, and all that. So there's two questions that we ask ourselves when we design an operating system. What should the classes or the objects be, and what features should these objects have? So when you design a chess game, for example, probably think about it for a while and then decide, okay, I need a class for all the 32 pieces, 16 on each side, 8 pawns on each side, and then the queen, king, and all that. And you have 2 players. So if you're setting up a game that's going to be played by, let's say, a computer, so you might want to have something like this. This is a feature. User-controlled, yes, would mean that it's actually an actual person. No would mean that it's some computer algorithm that's doing the playing for you. Okay, so we have questions like that whenever we design an object-oriented program. What features should these objects have? So at first you might not think of user-controlled versus computer-controlled, but pretty soon you do some playing, you set up automatic program that plays an actual user, and you might want to insert this data member, user control, true or false. Okay, so our initial goal is to learn to design and implement simple objects. That's all we're doing. That's all we want to do in this semester, actually, and this lecture too. We will assume that there are objects are there for the picking, or you're told you're supposed to have this class and this other class with these features and so on. So objects are designed to support system functionality. So if you're keeping track of, if you're designing a chess game program, you have to have the right kind of objects to make that chess game functionality come out. And system specifications are distributed as responsibilities to objects identified. So this is another piece of terminology that we will introduce in this chapter. This is used all over in programming, mainly actually quite a bit by some approaches that are used by IBM, but other companies too. So when you think of responsibilities that an object has, we think in terms of A, what an object must know, and they're called knowing responsibilities, and B, what an object must do, those are called doing responsibilities. So that's it, just knowing responsibilities, doing responsibilities. If you want to get to the full story, knowing responsibilities are just data members and query methods, and doing responsibilities are command methods and some queries. Okay, so that's really it. That, in a nutshell, is quite a bit of this chapter actually. Okay, so knowing responsibilities include knowing properties of the entity the object is modeling. So, for example, this player class models a player object or an actual player. And so what is important? Well, you need to know which color the player is, white or black, also whether it's an actual player, user controlled or computer controlled. So if user controlled is no or false, that means you can assume that it's computer controlled. You also need to keep track of, so each player object is sort of assigned a set of 16 pieces, or you can think of that as an array. So somewhere in here, player has to keep track of all of its pieces and then know about other objects like a piece object with which it needs to cooperate or use. So player will be responsible for knowing about all 16 of the player's pieces. So you can think of there being an array. It's not shown here, but that would be one way of doing this. So whether you have, let's say, player having to know about 16 pieces of his or her pieces, or let's say an album or a CD object knowing about however many, let's say 100 song objects that it needs to keep track of. Those are the kinds of things that we expect some objects to know about. Okay, so player models, for example, color and user controlled, but it also needs to know about its pieces too, its piece objects. Doing responsibilities include computing particular values, performing actions that modify the state. Remember, commands modify the state. Creating and initializing other objects, so that would be constructors. And then controlling and coordinating the activities of other objects. Okay, so roughly speaking, knowing responsibilities translate into data members that the object must maintain, or query methods. And doing responsibilities translate into commands or queries. So doing can be commands or queries, because there are some queries that you can think of as doing, like getting a value. You can think of that as doing, or you can think that as knowing, I guess. So queries like getters can be thought of as doing or sometimes knowing responsibilities. When we design a class, let's say we're given an assignment, or you're given a certain program that you have to set up, you have to design classes, and to design a class, each class, you have to determine the object's responsibilities, write them down, it's always a good idea, and then classify them as knowing or doing, and then figure out the knowing responsibilities. Should they be actual data members, or should they just be queries? For example, if you have a rectangle object, you would have a knowing responsibility of knowing about area. Well, do you really need to store the area, or can you just compute it from, let's say, other data members like length and width? In this case, you could. So if you have a rectangle class, you could make the area an actual data member, or you could just have it in general be a knowing responsibility that can be implemented using a query method, which can just compute the area from knowing the length and the width. Okay, so you want to think about these things carefully. So the general form of invoking a query is just the name of the object, my object dot query name, and then arguments. General form for invoking a command is just basically the same thing, name of the object dot command name and arguments. Typically you use the semicolon, that is, this is a complete, remember from the last set of lecture notes, this is a complete Java statement, whereas this may be a complete Java statement, but usually it's only part of an expression, or maybe it's an expression, a complete expression, or part of an expression. Okay, let's take a quick look at arguments versus parameters. Parameters and arguments are used interchangeably, but they actually have very specific and different meanings. So when you talk about a method like, let's say, move, direction and distance are the parameters. When you call it, you give it certain arguments. Okay, so in this case, it really should say parameters must match in number, type, and order. Or actually, arguments like these 90 and 2.5 should match these parameters. So once again, direction is a parameter of this move method, and so is distance. They are of type int and type double. And when you call it from a client class of this move, whatever class move is in, the arguments, which is what these things are, should match in number. So there's two of them here. There's two parameters. The type, this should be an int. First should be an int, and then it should be a double. And then the order, it should be int and double. Int first, double then next. Not the other way around. You would have, if you wanted to specify 2.5 first and 90 second, you could overload. You could have another method move with a double first, int second. So yeah, that could happen. So there is overloading and all that, but let's just ignore that for now. You want to have these arguments. When you call them method, the arguments, these are the arguments, should match the parameter type, number, and order. Okay, so a command, this is all old news for you, I hope. Command invocation is in the form of a statement. That is, when you call well, here's a nice example, move. So this is in the form of a single Java statement. Query is in the form of an expression. So this is a query. It's part of an expression. It could be the whole expression, and this expression on the right hand side is assigned, whatever value it has is assigned to I. It could also be a little bit more complicated, like this one is, where we have an actual expression. We say call this query method current count, add 10 to it. So this whole thing is a expression, and the current count is just part of that expression. Okay, so hopefully that's just review. Let's quickly just review local variables. I'm hoping that you've seen all of this before. A local variable is a method variable created as part of the method execution and is used to hold intermediate results needed during the computation inside the method. So it only lives as long as the method is executing. So let's say we have a retail item that includes instance variables. So this is a class with, whenever you see private, you know that that's a data member. So there's 3 double precision data members: base price, discount rate, and tax rate. And we want to implement a method called net price. We would say the net price is going to be public. It's going to return a double precision number, and it's going to calculate out the total cost of this item, including tax. So this is the kind of thing you would do. You'd have temporary variables. You'd use those temporary variables to store intermediate results of the computation, and then you'd compute out everything. The final computation is this addition, and then you return it. Remember this, whatever you return here, this expression has to be compatible with the return type. In this case, they're all doubles, so no problem. Okay, so these these variables are not data members. They are local variables inside this net price method. And in general, whenever you need local variables, this is much more preferred to creating new data variables. So there's no reason really, of course we have to look at the whole class as a whole, but there shouldn't be any reason to make these data members. If you're ever doubtful as to whether something should be local variables or data members, make them local variables. Make them local variables first, and then if you really need to, you might want to make one or a few of them data members. So minimize the number of data members, and you can create as many local variables as you want. It doesn't really cost all that much to make local variables. It is expensive to have a lot of data members. So I'll review the differences between local variables and instance variables in our next video, and then we'll move on to other topics.